There are plenty of reasons for a re-render to happen, and with the current way we are reporting everything, we're not actually going to get a whole lot of information on, okay, so I see that this update happened, but I don't know why it happened. What was the user doing that triggered this update? So that's where the experimental tracing API comes in handy. So we're going to import unstable trace, and I'm going to alias that as trace because I don't like the unstable prefix. And we'll import that from the scheduler tracing. And again, this is unstable, so the API could change sometime in the future. Maybe we won't be pulling it from the scheduler. Who knows? We don't really know. But this is kind of a preview of what is to come. So here we have trace, and we're going to instrument some user interaction with trace. And that interaction is this increment function. So what I'm going to do is I'm going to say trace this interaction, but the first argument for trace is the name of the thing that we're tracing. So this, we'll just call it a click. And then the second argument is when this interaction started. So here we're going to say performance.now, which is going to give us a timestamp for exactly when we are starting this trace. And then the last argument is a callback function for the thing that we want to have happen. And so now increment is a function that calls trace with an identifier of click. It starts right now. And this is what we want to have happen as part of this interaction. So we'll save that. And now we'll see our mount gets logged right here after 5 seconds. There it is. And then when I click, we'll wait another 5 seconds and we'll get another log here for the update. And we'll see we have an interaction right here that triggered that update. And there we've got our value, ID of 0. The name is click. And this is when it happened. And so now I have more information to help me understand what it was that triggered this update, and that can help me triage issues when we see spikes in our performance problems. The other cool thing about the Interaction Tracing API is under the Profiler tab here, if I begin a profile and then I do something that I'm tracing and then I stop my profile, then I can finally use this cool Profiled Interactions API right here, and that will show me that we had a click. And if I click on that one, then it's going to take me to the commit where that was traced. So if I record and then I click a bunch of times and then stop recording, then we can see we've got one click right here, one right here, one right here. And here we could do this click 1, 2, and then 3, 4, and then 5, 6, and then we'll stop. And here we have 1, 2, and then we had 2 more commits right here that were not profiled and not traced. And then we have 3, 4, and then 2 more clicks that were not profiled or traced, and then 5, 6. So that's a really cool way to get some additional information around what's triggering these different updates to help us triage performance problems in our application. So in review, what we did here was we imported the unstable trace, and we just aliased it to trace because I don't want to type unstable, but this could absolutely change. And then we're importing that from scheduler tracing. And then we took this increment, which is the interaction that we wanted to trace, and we took what we used to have and put it as the third argument. The first argument here to trace is the identifier for that trace. We can call that whatever we want. And then when that interaction started, and then we have that callback for what we actually want to have happen. And with that, React will allow us to use this really cool tool for the profiled interactions when we are profiling things. And we also have access to that in the profile information that React calls our onRender function with.